In this mini clip, we'll be focusing on the transformation of functions. While we answer this question together, you'll be solving the similar problem on your own using the same technique. Starting with f of x equal to the square root of x, we are asked to construct the graph of the negative square root of negative x plus 5. So to begin this question, we're going to graph our f of x equals to the square root of x. We should all be familiar with how this function looks once we graph it. It starts at 0, 0, and it moves up and eventually levels off. So this graph here will be titled f of x is equal to the square root of x. Now from this graph, we're going to apply our first transformation. The first transformation we'll be focusing on is this plus 5 here. So we will have to draw a second graph. Our second graph will be titled f of x equal to the square root of x plus 5. Now, adding a number to our x or subtracting a number will cause our original graph to horizontally shift. So in our case, because we are adding 5 units, this will cause our previous graph to shift 5 units to the left along the x-axis. So we know this point here is 0, 0 on our first graph. Because in our second graph we are adding 5, this means we need to take our first graph here and we need to shift all our points 5 units to the left. So if I take this point here, 0, 0, and shift it 5 units to the left, our new point will be negative 5, 0. Now because this function here is square rooted, just as it is in our previous graph, our second graph will have the exact same shape as our f of x equal to the square root of x graph here. Except instead of starting at 0, 0, our new graph will now start at negative 5, 0. So I'm going to draw the similar shape as we did in our first graph. I now want you to apply this first transformation to the function you are given in your question. This is how your graph should look. So coming back to our question here, we are now going to apply our second transformation, this negative in front of our x. So once again, we need to draw a new graph. This graph will be titled f of x is equal to the square root of negative x plus 5. Now we'll notice in this function here, we still have this x plus 5 all square rooted, as we did in our previous graph. The only difference now is we have this negative here. So we're going to apply this transformation from this graph here. Except now, wherever we have an x in this graph, we need to multiply it by this negative 1 out in front here. So looking at our previous graph, we know this point here is negative 5, 0. In our new graph, however, all our x's need to be multiplied by negative 1. So this point, negative 5, 0, once we multiply our x by negative 1, our new point on our graph will be positive 5 and 0. Okay, we would continue doing this with all our points. So for example, this point here, let's just assume this is where x was negative 4. Once we multiply by negative 1, it will be moved over here. So essentially what we're doing is that we're reflecting this graph here about the y-axis. So our new graph will look something similar to this. I now want you to apply this transformation to the question you are given. Here's how your graph should look. Now coming back to our question, we need to apply our last transformation, this negative in front of the square root. So we're going to draw our fourth graph now. So our fourth and final graph will be titled f of x is equal to the negative square root of negative x plus 5. Okay, so we still have the square root of negative x plus 5, so we want to apply our last transformation from our previous graph here. This negative outside of our function means that we are now going to multiply all our y values by negative 1. So if we look here on our previous graph, if all our y values are going to be multiplied by negative 1, we're actually going to have a reflection about the x-axis. This point here will remain the same because our y value is 0, and 0 times negative 1 is still 0. So we know our graph here will still start at the point, this is going to be positive 5, 0. However, if our y's now all become negative, they will now move down here. So this positive y will now move down here. This positive y will now move down here to the negative. So we are reflecting about the x-axis. So our last and final graph will look something similar to this. I now want you to try to apply this last transformation to the function you are given in your question. Here's how your final graph should look.